Hello friends, I am Krishna Kanjani from LG Institute of Engineering and Technology. Welcome to the online lecture series on kinematics and theory of machine. In this session, we will learn about velocity analysis. This session will cover up about the basic introduction and relative velocity method to solve numericals of velocity analysis. Okay, so let's start this session and learn basics of velocity analysis. So before starting with the velocity analysis, we have to learn few basic fundamental terms such as linear velocity. Now we are aware with that if a particle which is moving in a straight line, or we can say in a particular one direction, then this velocity which is measured along this direction is known as a linear velocity. Okay, now the second fundamental, now if you want to calculate the linear velocity, then you have a simple equation, that is the linear velocity v is equal to change in distance, or we can say displacement per unit time. Okay, so this is the basic equation which is used to calculate linear velocity. Now second fundamental, that is known as angular velocity. Now if a particle, for example this particle which is placed at point A is moving from point A to point B, which is known as a angular velocity. Okay, because now it is moving in a motion of a body in a circular path. Okay, so in this case the velocity is measured as angular velocity omega. So now to calculate this angular velocity, we have basic fundamental, that now we have to consider that angular velocity omega, that is equal to change in again displacement. Now if we consider displacement as s, so ds by dt, this equation will give you the value of angular velocity. Okay, now let's consider few basic terminology, that if we consider r as radius, theta as angular displacement, s as linear displacement, and v as linear velocity. So now over here first we have to calculate the value of s. Now over here we can say that angle is equal to arc upon radius, or we can say arc is equal to radius into angle. So we can calculate that linear displacement, in this case we can say s is equal to r into theta. Okay, now by using this relation we will derive the relation between linear velocity and angular velocity. Okay, so to derive that relation, let's start with the linear velocity. V is equal to ds by dt. Now over here we have the value of linear displacement as r into theta, so we have to put s is equal to r into theta. Now here in this equation, the r which is denoting the radius of this circle, so now radius will remain always constant, so we have to put this r outside of this derivation, so we can say r into d theta by dt. But this term over here, now we can say that change in angular displacement with change in time is known as a angular velocity omega. So over here we can say v is equal to r into omega, and this is the basic relation between linear and angular velocity. This equation is prerequisite for the calculation of velocity analysis. Okay, now next fundamentals, let's learn what is relative velocity in two different components. So let's again consider a particle A which is moving with velocity v. So over here we can say velocity of particle A in this direction, which is denoted by this line. Okay, now this line is the measurement that how much it is with how much speed this particle or this body is moving. For example, if you are driving your vehicle, then in your speedometer what the speed is denoted is you can say as a linear velocity of your particular body, or you can say linear velocity of your vehicle. So over here if you consider that if you are moving your vehicle with 50 km/h speed, so 50 is your speed, and this speed is measured with reference. Which reference? How will you measure this 50? Because if you are measuring, or if you are considering displacement of any one body, then for that displacement you have to identify certain point as your fixation or as your relative, because if you are measuring displacement from this point, so over here if you consider this line as a line of having point OA, so in this diagram, we can say the particle is moving from point A to point O to point A. So over here we can say that this O is your reference point and that is your fixation point, because with reference to this fixation your particle is moving in this direction with this amount. Okay, similar way you can say that if you are driving your vehicle with 50 km/h, so over there your speed is measured with respect to the fixation, that is earth. If you consider that with respect to the earth, your particle or your body, your vehicle which is moving with 50 km/h speed. Okay, so that is known as the absolute velocity of that body. Similar way we can consider that another body which is moving with velocity v. Over here let's consider it is moving with velocity v. So in that case, now your particle which is moving, for example let's consider your another vehicle, let's consider another bike or another vehicle which is moving at 30 km/h speed. So that 30 km/h is known as absolute velocity of that particular body. Okay, because it is again measured with reference to this fixation. Okay, so this is the basic terminology which is known as this 50 and 30 are known as the absolute velocity of the body. Now here comes the second term which is known as a relative velocity. Now if you want to measure that the with reference to point A, what is the velocity of point B, or we can say with reference to point B, what is the velocity of point A. So this relation between these two particles is known as a relative velocity. Okay, let's consider one more example, that if a train is moving on track. Okay, so if you consider a train which is moving in a track. Okay, so here the velocity of train is known as absolute velocity of the train, because it is measured with reference to the fixation or track. Okay, now let's consider one person which is sitting in this train wants to travel inside this train. So if this person is moving from one compartment to another compartment. Okay, so over here you have to measure the velocity of this person with reference to, because now if a person is moving from first compartment to second compartment, now if you are measuring that speed with reference to your train, then it is known as a relative velocity, because you are calculating the velocity of any body with reference to another body which is also moving. Okay, so over here we can say this is known as a relative velocity. Over here the relation between A and B, that is again termed as a relative velocity. Now this relative velocity is very important term to learn or to calculate the velocity of different point in a mechanism, because in a mechanism if you are considering that it is a 4-bar chain mechanism, let's consider a mechanism which is a 4-bar chain mechanism. So now over here in this 4-bar chain mechanism, if you are rotating any point or any link with respect to this fixation, that is link number 1, if you are rotating this link number 2, then it will have a certain amount of velocity. Similarly with respect to this 2, 3 will be moving, so that is known as a relative velocity of third link with respect to the second link. So in this way we will learn or we will I can say that we will use this fundamental to calculate velocity of different links. Okay, so now let's learn that how we will calculate this relative velocity. Okay, so now over here we have learned that A is moving with VA and B particle is moving with VB. So now if I want to calculate that the relation between A and B, that is the velocity, over here we can say that velocity of point A with reference to point B. Okay, so over here point A is here and point B, we have simply sketched this. This is a graphical method in which we are simply plotting that amount. So over here velocity of B, so this difference is known as the velocity of point A with reference to point B. Okay, so how we can calculate? Simply the vector difference of VA and VB. Let's consider VA as your vector of velocity of point A and VB as vector of velocity of point B. So over here we can say that with reference to OA, which is defining velocity of A, and OB is defining velocity of point B. So VA minus VB, or we can say OA minus OB, that will give you the velocity of point A with reference to point B. Now, if a person wants to calculate velocity of point B with reference to A, then it is also possible. Okay, because we can calculate in counter direction also. So if we consider that I want to calculate velocity of point B with reference to point A, so now what will occur over here? Now you are measuring velocity of point B with reference to A. So over here your equation will be reverted. We can say that vector difference between velocity of B minus A. So that we can say for velocity of B, we can say that velocity of B is OB. So over here OB minus OA, that will give you vector AB, and that is velocity of B with reference to A. Okay, so now in this way we can calculate relative velocity of different elements. Now from this equation even we can say that velocity of A with reference to B, or we can say B with reference to A, will be having always the same amount, but it is in opposite direction. If you refer over here, then in B velocity of A, or we can say A is moving in direction of this, we can say positive x direction comparison to point B, or in other word we can say B is moving in negative x direction with reference to point A, because timely it will having a different amount which is in a negative x direction. Okay, so in this way we can say that VA is equal to minus of BA, because the magnitude will be same, only the direction is changing. Now let's consider a particle which is having inclined, or which is having different direction. For example, A is moving in this direction and B is inclined, or B is moving in some different direction. So over here if you want to calculate the velocity of point B with reference to point A, then here in this case you have to also plot a simple diagram. Let's consider this is defining, let's consider this one as a point fixation O. So with reference to point O, it is your point A which is defining velocity of A. If you consider with reference to O, this is your point B which is defining velocity of point B. So now if you join these two, then it is termed as a velocity of B with reference to A, because velocity of B with reference to A is simple. The equation remains always same, that vector difference between B and A. So how we can calculate this vector difference BA? By joining these two lines. Okay, so we can simply sketch this diagram in such a way that velocity of B and velocity of A, so line joining this A and B is defining your velocity of B with reference to A. If you are taking your direction, if you are considering your arrow head towards that point, will be defining as velocity of that point. If you put your head in direction of point A, then over here it is known as the velocity of A with reference to B, and that will be in a upward direction. If you want to calculate velocity of B, then it will be in a downward direction. Okay, so simply by using this graphical method we can calculate relative velocity of different points. Okay, this is a very essential prerequisite which is required to learn velocity analysis. Okay, now let's learn motion of a link, that how motion occurs in a link. So let's consider a link AB. Now if we consider this link AB, then it can move in two directions if you consider it as a planar arrangement or planar mechanism. So when a link is lying in a simple one plane, then it is termed as a planar arrangement. So this mechanism or this link is known as a planar link. Okay, so now how this link can move? So with reference to point A, if you are applying force on point B, so either it may be possible that the whole AB link, let's consider over here, this one is your point A and this one is your point B. If you applying force over here, so either it may be possible it will directly move in X direction, the whole entire link will move in X direction. Either we can say by applying force it can rotate. Okay, so in that case it will be rotating in this way. So we can say either it will translate in one direction and either it can rotate. So let's consider it is translating as well as rotating. So in that case you are not able to identify, because if you consider after this is your position number 1, and if you consider this is your final position, position number 2. Now you cannot able to identify either it has translated first and then rotated, or we can say it has rotated first and then translated in this direction. Okay, so overall what we are able to understand that this one is position 1 and this one is position 2. Okay, so over here we can simply say that the position of link can either translate or rotate, but we cannot able to identify that which motion had occurred first. So we have to generally consider that both the motions are taking parallelly, taking their actions parallelly. Okay, now in this case let's consider a link which is having notation point A at one point and point B and another point. Okay, now if you apply force at point A with reference to point B, okay, this is very basic fundamental. If you are applying force, if you are fixing this point, you are not moving this point A, because the distance between A and B cannot change because it is a rigid link, and the distance between rigid link or rigid particles will never change. So over here if you are applying force on point B, then in any circumstances the motion of point B will not occur in forward upward direction or in downward direction, because this distance has to remain constant because it is a rigid body. Okay, so now what is the second fundamental? Now if you are still applying force, then what will happen? It will try to rotate, or we can say that point B is moving in this direction because it has to move always in perpendicular direction. If you are considering force, then it cannot move in this direction also, because in that case the distance between A and B will change. So the only possibility in which the distance between A and B will not change is that the possibility in which the motion of point B occurs perpendicular to point A, and this perpendicular to the line which is joining point A and B. Clear? So over here you can learn that simply in any of the mechanism, the motion of any link will occur always perpendicular to the direction of line joining two endpoints of this link. Okay, and this is known as a simple motion of link. Now from this fundamental you are able to identify that if you want to calculate the velocity of point A with reference to point B, then you can simply consider that it is perpendicular to the line joining these 2 points, or we can say in this direction. Okay, now similar way let's consider the calculation. So over here we can say velocity of B with reference to A is equal to your vector AB, which is always in a perpendicular direction to the line joining these 2 points. Okay, and how we can calculate? Now we have a simple relation, V is equal to R into omega, that we have derived in just previous slide. Okay, so V is equal to R omega. So over here we can say R is equal to radius, and radius is equal to nothing but the distance between these 2 points, so that is capital AB. So we can say omega into AB is defining the motion, and this omega into AB is defining the magnitude of the velocity of point B with reference to point A. Okay, now similar way, if you consider any arbitrary point C which is lying on the same line AB. Okay, so in that case the motion of C will be always also perpendicular to the line joining A and C, which is similar to the BA. Or you can say if you are considering point D on link AB, again what will be the direction of point D? Again it is perpendicular to this. So overall any point on this rigid link, if you are considering or if you want to calculate velocity of that point, then it will be always in the same direction of VBA, or we can say velocity of B with reference to A. Okay, so in this way it is lying on the same line. And how will you calculate the magnitude of this line AC? So for that you can use the relation. So let's consider VCA, that is velocity of point C with reference to A, that can be calculated by again omega into R. Now here omega will remain the same because both the points are lying on the same line, so the angular velocity will be same for both the points. So over here omega is remaining constant, only the distance AC is changing. Okay, so now if you consider the relation VCA upon VBA, or we can say is equal to AC upon AB. Okay, so over here the distance is AC upon AB, so it will cancel out this omega term, because omega AC upon omega AB, that is equal to AC upon EB. So in this way you can simply say that if you want to calculate velocity of any point on a rigid link, then you can calculate by the distance of, by the ratio of the distances from this reference point. Okay, so in this way this equation is very essential to calculate velocity of any point on the rigid link. Okay, so from this we can conclude that if you consider a rigid link, that in case of rigid link the direction of motion, or we can say direction of velocity, is always perpendicular to the line which is joining these 2 points. Okay, now second term or second element, let's consider after rigid link we can always face with another element that is known as a slider. Now what will happen in case of slider? Now if you observe that the pattern or the motion of slider, then it is always restricted in particular direction. So if you are moving your slider in this direction, so then velocity of the slider will be always also in the same direction. Over here you cannot use the fundamental of perpendicular, because if you consider the motion of slider, if you are taking it in horizontal direction, then the velocity will be always also in the same direction, that is in horizontal direction. Either it is, if you are placing your slider in vertical direction, let's consider this arrangement. So over here if you are making motion of this slider in vertical direction, then the velocity will be always also in the same direction of motion. So for slider we have to remember that the direction of velocity is in the same which is in the direction of the motion. Okay, so these two fundamentals are very useful to learn the motion of a link. Okay, so over here we are concluding that to learn velocity analysis, we have to remember these two fundamentals. Okay, thank you.